All right. Number one says, oh man, I messed it up. Oh well. Number one says we have to grab 2 to the negative x plus 4 power. All right. So first we need to talk about the 2 to the negative x. So 2 raised to the negative x power. Oh, come on now. 2 raised to the negative x power is the same thing as saying 1/2 raised to the x. So remember when we have this stuff here, a to the x. If a is greater than 1, we know that is going to be, it's going to look like this. It's going to be increasing. When a is less than, it's between 0 and 1, so pretty much anything less than 1 or greater than 0. Let's just do this in a different color. It's going to be a decreasing function. So if a is greater than 0 but less than 1, it is going to be a decreasing function. Okay? So since it's 2 to the negative x, we know it's going to be decreasing. All right? So also, so now we're also going to have to move this up 4 units. So we move everything up 4 units. So we do a quick sketch. Again, this is say it has to be perfect. So at 1 means we have to go up 4 more. So it's 1, 2, 3, 4. Okay? So that means at 4, this is going to be our horizontal asymptote. Because remember, when you put this to infinity, this is 0. This approaches 0. 0 plus 4 is 4. So this is never going to be less than 4. Okay? Alright? So as always, this goes from here all the way down and passes at 5 and approaches 4, but it never crosses 4. Okay? But if you can just go ahead and try it in your calculator, go ahead and plug this into your calculator, and you'll see that it never crosses 4, no matter how big of an x you put. Alright, the next one we have to graph is log base 3 of x plus 3. So first I'll just graph regular log plus 3, okay? So it keeps going up. So this is 1. Remember, those crosses at 1. Then at 3, it's going to be 1, okay? Because the log base 3 of 3 is just 1, okay? So this is just log base 3 of x, alright? So log base 3 of x. So now we have plus 3, right? So remember what I told you last time. If it's inside, it's opposite of what you think. So it's plus. Plus is this way, right? But we're doing so since we said it was opposite, we have to move it to the left 3 units. So we move it over to the left 3 units. So that's 1, 2, 3. This is negative 2. And this is negative 3. So our vertical asymptote is going to be at negative 3. This point belongs here. Move this over 3 units. 1, 1, 2, 3. So that point is there. So now it still follows the same pattern. So it goes like that. So this is this line. Okay. So remember when we did transformations first of the absolute value, parabola, and all that crap. You always have to know how the parent function looks like, and then you just move it up or down, left or right. Okay. So since we had this is how log base 3 of x looks like. So we have x plus 3, log of quantity x plus 3. You have to move everything to the left 3 units. So you move it over 3 units. So it's 1, 2, 3. 1, 2, 3. So you know you have to do your vertical asymptote is going to be at negative 3. This point is 1, 2, 3 is going to be at negative 2. This point is going to be at 0. That's basically it right there for that one. All right, number 2, write the equation. So you have to write the equation 6 to the 2x is equal to 25 as a log. Alright, so remember, it's log of the base of your answer of x. Okay, so it's going to be log base 6, you basis 6 of 25 has to go to 2x. Okay, that's pretty much it. So log base 6 of 25 is equal to 2x. Alright, you can also change this to, if you evaluate this, remember this brings up to 6 to this is the same thing. Let me raise to the 2x power. Yeah, raise to the x power. So it's just 36 raised to the x power has to be 25. Okay, so you can also write log base 36 of 25 is equal to x. So I don't know which way your professor is going to want it. As they're both the same way, they're both going to be pretty much the same thing, the same answer. It doesn't matter which way he wants it. It's going to be the same thing. Okay. So remember, you just have to transform it. So the next one's going to be working the opposite way. It's the natural log of a is equal to 3. So natural log is just the log with a base of e. Okay. So once you write this in exponential form, we know we're going to use e. So this is e to the third power is going to give you a. It's still the same thing, right? Our bases are the same. Base is e. So like 6, right? e. Our power was the answer, so our answer is the power. So it's e cubed is equal to a. All right, that's pretty much it. Really simple. All right, next one up. Find the exact value for each expression. We have 10 of log of 36. So log of 36, you can do that. So you can just cancel out. So the 10 raised to the log 10 power cancels out. So you're left with just 36. You always have to be sure if you can do the inside function first. Since you can do that, you can just cancel them out. Next one is the natural log of e to the third. You can do this as well. Natural log and e cancel out, so you're just left with 3. So your log 3 of square root of 27. So square root of 27, if you rewrite this as the log of 3 of 27 raised to the 1/2 power, right? Using the log rules is 1/2 times log base 3 of 27. Well, log base 3 of 27, you rewrite this as 3x is equal to 27. So x is, what was that, 3? So you have 1/2 times 3. This is just 3 halves. Okay. Whenever you have square roots or whatever, write it and in the exponent terms, and then just use your rules. So you move the 1/2, you move the exponent to the front, and then evaluate your log. All right. Next one is log. Was that base 2 of 80 minus log base 2 of 10? All right, you're like, whoa, I don't know log base 2 of 80 or log base 2 of 10. It's just true. You don't. It's not 2 raised to any power. It's not going to give you 10. I mean, any even power, any integer, it's not going to give you 10. And 2 raised to any other integer, it's not going to give you 80. But this one you have to reuse. You have to use your things of logs, right? So when you're subtracting them, you divide the insides. So this becomes log base 2 of 80 over 10. This brings up to log base 2. 80 divided by 10 is just 8. Now this you do know. So it's 2 to the x is equal to 8. So x is 3. So log base 2 of 8 is just 3. Alright. Next one up is log base 8 of 4. Log base 8 of 4. Let's see. 4. This is a hard one. Alright. So it's going to be 8 to the x is equal to 4, right? Because you want to find the answer to say x. So it becomes this. Alright. So you got to think about what do these two numbers have in common? A number raised to another number, it's going to give me 8, and that same number raised to a different number is going to give me 4. Well, that is going to be just 2. So 8 is 2 to the third power, and 4 is 2 squared. So we're going to go ahead and rewrite it. So instead of writing 8x, 8 to the x power, we write 2 to the third power to the x power is equal to 2 squared. Alright, so now you have 2 to the 3x is equal to 2 squared. Since your bases are the same, you just set the exponents equal to each other. So you have 3x is equal to 2, x is equal to 2/3. Not bad, right? So even though sometimes you're going to get problems like this, you want to think of what bases they have in common. In this case, it was going to be 2. All right, the next one up, I didn't give myself a crap. I think I can do it in here. It's log base 6 of 4 plus log base 6 of 9. Again, 6 is raised to any integer, it's not going to give you 4. 6 raised to any integer, it's not going to give you 9. So we have to combine these two logs. So since you are adding them, you're going to multiply. So 4 times 9 is 36. So now this you can do. So this is 6 to the x power is equal to 36. X is just 2. So x is 2. Alright, so you have to keep reusing your rules in order to do this type of stuff. So this is 1, 2, 3. 1, 2, and 3, and all the A, B's, and A through F's. Alright, the next video is going to be 4 through 7. Hopefully all those fit on one page. Alright.